Okay, this lesson is on fractions to decimals and decimals to fractions. I'm going to go over a few examples on how to do that just to give you some added help with this lesson. The first thing they'll ask you to do is to convert fractions to decimals. So for example, if we have 4/5 and we want to convert it to a decimal, we just divide. So 4 goes in the box, 5 is outside, and we look and we know that 5 can't go into 4. So here's where the decimal part comes in. I can always rewrite a number by putting a decimal and then a 0 because it doesn't change the value. So now I look at it and go, what times 5 gives me 40? And so 5 goes into 40 8 times. So 8 times 5 is 40, subtract and we get 0. Now the decimal that was here goes straight up to the top. They definitely line up. And so 4/5 we realize is the same as 0.8. Now what if this were a negative 4/5? Then our answer would be the same, but it would be negative 0.8. Converting decimals to fractions. So if I have 0.36, I want to know what that was as a fraction. If we look at the place values of this is the tenths, that's where the 3 is sitting, and this is the hundredths, that's where the 6 is sitting. So we always go with the bigger one, and so we write 36 without the decimal over 100. Now of course we always want to reduce our fractions. So if we divide by 2, then we get 18 over 50. If we divide by 2 again, we get 9 over 25, and that's as good as it gets. So we know 0.36 is the same as 9/25. And again, what if this was negative 0.36? Then we would get negative 9/25. Now for the kind of strange part that happens is we can divide two numbers and end up with a repeating decimal. So what we want to be able to do is go from the repeating decimal back to the fraction, or the two numbers that were divided. So for example, if I have 0.6 with a bar over that, that means that that's 0.6666 on and on and on forever. So we do a little bit of some algebra, a little bit of kind of math magic to get this back into fraction form. So I'm going to give this a name. I'm going to say that x is this 0.6666 repeating. Now what I can do is take this entire thing and multiply it by a number. I want to multiply it by 10. So 10 times x is 10x. If I multiply 10 by this decimal, what happens is my decimal point just moves one space over. So I would get 6.6666 repeating. Now what I want to do is I want to subtract these two ideas. So 10x equals 6.666 repeating, and I want to subtract x equals 0.666 repeating. Now what does that mean for this problem is that if I subtract, notice these all go to 0 when I subtract. So I've eliminated the repeating part. All I'm left with is 6 minus 0, which is 6. Over here I have 10 minus 1, so remember there's a 1 here. 10 minus 1 is 9x. And last but not least, we want to simplify and answer this algebra question. So we divide by 9 on both sides. We get x equals 6/9, and reduce, of course. So if we divide by 3, we get 2/3. So what we found is that 0.6 repeating is the same as 2/3. Now, what if we have more than just one repeating number. So for example, what if we have 0.81 with the bar above both numbers? Well, that means that we have 0.81, 81, 81, 81 repeating. So same kind of process. X equals 0.818181. And here we don't want to necessarily multiply by 10 because we have more numbers. So just like when we are dividing that first decimal into a fraction, we took the place value into consideration. We do that here. So this is hundredths. We want to multiply by 100. So 100 times x is 100x. Multiplying this decimal by 100 means that the decimal moved 2 places over. So we have 81.818181 repeating. Again, we want to subtract these two ideas. So 100x equals 81.818181 minus x equals 0.818181. Now, in subtracting these, what do we notice? Well, they subtract to 0. So all of the repeating part disappears. 81 minus 0 is 81. And remember there's a 1 here. So 100 minus 1 is 99x. Again, solve this equation. So we want to divide by 99. And we get x equals 81 over 99. Now we want to reduce, so if we divide top and bottom by 9, we get 9/11. So we know that 0.81 repeating is the same as 9/11. Now one last thing that might happen is that we could, if we had divided two numbers, received a repeating decimal, but maybe not all of it is repeating. So for example, 0.87, but just the 7 is repeating. So we have an 8 sitting there, but the 7 is repeating. So what this looks like is 0.877777, and so forth. So let's start out with that same process. X equals 0.877777 repeating. If I multiply this by 10, I would get 8.77777. Now let's look at kind of some scratch paper over here. If I subtract that, these go to 0, but notice right here, that is not going to give us a 0. So we can't subtract those. It doesn't work out. We didn't line it up correctly. So what if I multiply it by 100 like we did on the last one? I would get 87.77 repeating. Now again, let's take a look at what that means. I would have 87.77 repeating minus 0.877 repeating. Now again, zeros disappear, but what happens here? Still didn't line up correctly. So this one uses one little trick, and that is we are going to subtract these two ideas. So we're not going to worry about this one here. So we have 100x equals 87.77 repeating minus 10x, which is 8.7 repeating. And what do we notice? Well, all of the repeating part disappears now, which is what we were looking for. We have 87 minus 8 gives us 79. 100 minus 10 is 90. Again, solve, so we divide both sides by 90. And so x equals 79/90, and that's as good as it gets. There is no reducing that fraction. So 0.87 with just the 7 repeating is the same as 79/90ths. So that concludes this lesson. So what you're going to do is give me a call at any time during my hours, and we'll talk about this recording, and then that will give you credit for the recording, and then you can go on to do the homework problems associated with this particular lesson. Have a great day. Okay, this lesson is on fractions to decimals and decimals to fractions.